Hi guys, it's Mrs. Trosvik again down in house 6B. Today we're going to talk about prime and composite numbers. Yesterday we talked about divisibility, whether or not a number was able to be divided by another number. So let's review. What is a prime number? A prime number is a number that is greater than 1 and can only be divided by 1 and the number itself. A great example is 17. 17 can only be divided by the number 1 and 17. That means that 1 times 17 is the only multiplication problem that will give me the answer of 17. So that means it can only be divided by these two numbers, these two factors. Composite number. A composite number is a number greater than 1 that can be divided by 1 itself and at least one more number besides 1 and itself. So an example would be 16. I can multiply 1 times 16 to get 16, but I can also multiply 2 times 8 to get 16 and 4 times 4 to get 16. So 16 is divisible by 1, 16, 2, 8, and 4. And then we write them in numerical order. So least to greatest, 1, 2, 4, 8, 16. That's what makes this a composite number. We have more than just 1 and 16 that we can multiply to get that answer, which means we can divide out more than just 1 and 16. All right, here's a list of some prime numbers. Here's a list of some composite numbers that are common. We're going to start down below by working with the numbers down below. So what are the factors? Factors are simply just the numbers that go into a multiplication problem to get that answer. So our answer is 3. What numbers can we multiply to get 3? Well, we can multiply 1 and 3. 1 and 3. And we're going to put a comma in between it when we make a list of factors, and we're going to list them least to greatest. I'm going to give you a little hint and a little cheat of how to do that the easiest way. Since these are the only two numbers I can multiply together to get the answer of 3, this is considered a prime number. All right, let's look at 5. We can multiply 1 times 5, and that's it. There are no other numbers. 2 times no number equals 5 unless there's a decimal, and we can't have a decimal for it to be a composite. In order for it to be composite, it has to be a whole number. So 1 and 5 are the only two numbers I can multiply together to get 5. 5 can only be divided by 1 or 5. So therefore, this is also a prime number. Number 6, we can take and multiply 1 times 6. That's the easy one. And I'm going to do this in a really weird way. I'm going to put the smallest number, which is 1, and 6, which is the greatest number I can have, go into 6 at the end, because 6 is the number I want for an answer. But I do know that there are two other numbers I can multiply together to get 6, and that's 2 times 3. So I'm going to put them in numerical order. 1, 2, 3, 6. If it helps you, you can just simply make a list of all the multiples. 1 times 6 and 2 times 3. Those are my problems that I can multiply together to get 6. So therefore, these are my factors of 6. Since there are more than just 1 and 6, then this is a composite number. All right, number 10. I'm going to go and do it a little bit different so you can see it maybe easier this way. 1 times 10 is the obvious one. We know that 1 times 10 equals 10. 2 times 5, you all know. 5 times 2 as well. Remember multiplication, it doesn't matter which direction we go. 5 times 2 is the same as 2 times 5. There's no number times 3 that equals 10. There's no number times 4 that equals 10, 6, 7, 8, or 9. So therefore, these are my factors. I'm going to take 1. I'm going to take 2. I'm going to take 5, and I'm going to take 10, and I'm going to make them in a list from least to greatest. Since I have more than just 1 and 10 as factors, this is a composite number. Number 12, we're going to do next. Number 12, I can take 1 times 12, 2 times 6, 3 times 4, and I know there's no number times 5, but I also used 6 already. There's no number times 7. There's no number times 8 that equals 12, 9, 10, or 11. So therefore, these are all my factors of 12. I'm going to start least to greatest. 1, 2, 3, 4, 6, and 12. These are all the factors of 12. Therefore, this is a composite number. All right, let's go to 15. 15, I have 1 times 15, 2 times nothing, 3 times 5, 4 times nothing. I already used 5. There's 6 times nothing, 7, nope, 8, nope, 9, nope, 10, nope. I'm done. Here are all my factors. 1, 3, 5, and 15. Since these are more than just 1 and 15, this is a composite number. And last one, 24. I can take 1 times 24, 2 times 12, 3 times 6, 4. Oh, I made a mistake. Sorry. 3 times 8. Remember, teachers make mistakes too. In my class, I give them treats if they catch my mistake. Don't tell anyone. 3 times 8, 4 times 6. There's no number times 5 that equals 24. There's no number times 7. We already used 6, 8. There's no number times 9 that equals 24. And 10 or 11. So I think I'm pretty well off. Here are all my factors, least to greatest. 1, 2, 3, 4, 6, 8, 12, and lastly 24. That's a lot of factors of 24, so therefore this is a composite number. It is not prime. All right, remember, if you can only divide or by itself and 1, it is a prime number. If you can divide by more than 1 in itself, then it is a composite number. And remember, the opposite of division is multiply. So sometimes the easiest way is just to write out the multiplication problems to get all of your factors and broken apart into pieces. All right. I want you to write down what patterns did you notice in the prime and composite numbers that we did so far. When you are done, you are going to go on and do the student page, lesson 5, unit 5. And you need to tell me all the factors of each of these numbers and whether or not they are prime and composite. Or prime or composite, my apologies. All right, guys, well, good luck. Have a good day. Take care.